Hi, this is Henrik Rexed from Neotys. Welcome to this session. We will have 45-minute sessions in total about transforming testing by combining NeoLoad and Inflectra. So there will be, of course, a couple of slides at the beginning to see the topic in details, a couple of features that are pretty much important to make this possible, and then we will jump directly to a hands-on demonstration where we're going to see, first of all, the current official integration that is available here, and then a trick to take advantage of the platform, NeoWeb as well. So let's start and see you later on for the Q&A. All right, so who is the speaker? So my name is Henrik Rexed. I come from the north, so I have the Viking blood in my vein, and I'm a big kid. So I have a lot of Legos, and you see that I have lots of Legos here and there in the presentation. So don't be surprised; it's normal. Otherwise, I've been working in the performance industry more than 15 years now, and what I'm doing at Neotys, I am the technical partner advocate, I would say, that builds solutions, integrations, look at innovation stuff. So if you combine the Viking with the Lego, you will get that character, Night Loader, in LinkedIn, Twitter, and others. So don't be surprised. I usually don't use my own picture on the social medias. All right. So like I mentioned, we have a pretty tough agenda. So going through various topics here. First, I'd like to remind the challenges of the performance, and then to add to those challenges, we recently did a survey and we published the state of performance engineering. And I'd like to share a few numbers that we observed here on the market. Of course, we're going to jump into the importance of testing earlier. Including performance in pipelines, and also how to be smart in the evaluation of your test and communicating around your the results that you come out from performance. Before we jump to the demo, couple of slides just to show how important, what are the features that make sense and that will help you. And last, we will jump to the demo and show the product demonstration. So we recently did a small webinar on retailer, the retail market. And we did a survey. We collected some survey about the usage of the consumers with the COVID-19. So we've been all locked down. So naturally, if we want to buy things, we were primarily using the online. So there was been an increase of 37% of people buying online for delivery, and 29% buying online for pickup in stores, so like driving. So that shows that people were already buying online, but that has added a significant increase in terms of number of users that basically changed the way they're consuming. And I think in the future, and that's one of the results, is 38% says that they're going to mostly likely to continue this behavior after the post-COVID. So, and we expect from the next Black Friday or from the Christmas shopping, a significant increase of traffic on those major retailer platforms. And also one thing is, even if we were born in the 80s and we've been used to have a slow connections and bad devices, not that bad devices, but devices that were less powerful than we have at the moment. Now we've been used to have good hardware and internet. So our expectations in terms of performance is quite high. If I go to restaurants and I wait a lot, I could be frustrated just to wait. At the moment, waiting is something that we don't like at all, and we can express our frustration in various ways, either on social networks, either by by just quitting and going somewhere else, or impacting on the current business for the application, the organization. So response times is very pretty much important. And during this COVID-19 situation as well, a lot of big organizations had already started their journey for digital transformation. But if they did not do that before, um, the situation forced them to transform themselves. Otherwise, they could basically close business. So it's important, and part of the digital transformation performance is obviously super important. The other thing that changed the last 15 years is the way we deliver software. I mean, 15 years ago, we were all at waterfall, going through 6+ distinct steps. Um, Performers were in between acceptance and deployment. So we were planning 2 weeks of work, and suddenly dev shifted a bit, testing as well. So instead of having 2 weeks of work, we only had like 4 days. So we like firefighter doing everything we did our best to deliver, detecting problems, but we didn't have much influence in the organization. So a bit frustrating as of that. Incremental change a bit, but nothing much for us, for performance engineers. And I think with Agile, this is where everything started to change, because shorter cycles, uh, testing at the end of the release doesn't make sense. A lot of things happen during the development, and DevOps is even worse. So that the change of delivery has basically changed from the moment we shift to Agile. And a lot of us is already on Agile. The second thing that I like to compare or to highlight is performance testing is exactly similar to going to the gym. One American out of 5 has a subscription at a club or a studio, and the same thing. A lot of companies has invested in load and performance testing tools, so they already have the things. But what is interesting is, why do they open a subscription or buy a product? Usually, it's based on resolution. So I'm Christmas. I eat. I see my family. I eat. I drink. Then I have a New Year's Eve where I do the same thing. And then I say, actually, this year, big resolution. I'm going to do a lot of sport, so I'm going to take a membership here. So 12% sign up in January, which is quite impressive. And it's the same thing with performance. People usually start buying tools from the moment they hit the wall. They have had a major performance problem, and that impacted significantly the business. So say we have to change. And also the problem, you can have those resolution, but after a few weeks, max 24, uh, people is not going to the gym anymore. They lost completely their courage, their motivation, so they just stopped it. And the same thing, people, instead of doing day-to-day performance, they do once or twice a year a big bang load testing, and maybe that's not the right thing to do. And last 50%, they are going to the gym only to find their soulmate, and it's exactly the same thing. You usually start doing performance testing because you know that those performance engineers, they are pretty much very attractive, so you want to do performance engineer just to meet those people. That's for sure. the, the the other thing that does change as well is the way we design our app. So if we a few years back, we were mainly touching monolithic or 3-tier architecture with presentation layer, business layer, database. And if we take just the example of those business layer, we had all the logic of our business there quite heavy. So we were building a big binary and deploying that big binary on a server hosted internally. And if we had more power, we need to add extra server where we deploy the entire stack. So not much about scale or elasticity at that time. So we were quite a lot on prem, very hard to do early performance engineering because a lot of dependencies here. Now, microservices. Microservices is pretty amazing, I think, because first you can split in the organization by having small teams leading one of the main couple of services in charge of their code and their database. They can have their own pipeline to deploy things, and one of the output of coming out as a release is going to be a container. So then once you move to another state, like staging, for example, you just have to assemble those various containers to each other to have an assembled app. So this is pretty much um, a revolution, because the way we are structuring our dev or pipelines, but also it's pretty much aligned with all the concept of cloud native architecture. So once we move there, we say, hey, we're going to move to the cloud. And if you look at the marketing messages related to that, say, hey, if you move to the cloud, you're going to reduce cost. You're going to increase the availability of the application. You're going to simplify. You're going to modernize. But there is always a but. Because if you ship to production bad consuming code, you have maybe elasticity involved. So you will deploy and utilize more resources, more nodes. So that will probably add an extra zero to your Amazon billing at the end of the month. So performance is not only about response times. There's other things that you should pay attention to, and especially how much resources your app is eating to control the cost of your deployments. So, like I said, we did a state of a survey. We asked questions to 515 people, persons, organizations, in various countries and business, and we came up with a state of performance engineering. And from there, I'd like to share a couple of challenges that has been expressed, and I think it shows how the market is at the moment. So one of the things is 15% of the organization, part of the survey, they are not correlated. They are correlated app performance with business metrics, which is pretty much low. And you see that business is definitely a key element to make a successful performance engineering methodology. 80% includes performance as part of the definition of done. So it means it's not part of the pipelines so much, only 80%. So that is pretty much scary from my perspective. And then 67% is still utilizing those central teams like COE. And those, they cannot react based on the importance of running tests on day-to-day basis, on the releases. So COE could be basically a break to implement on a real performance engineering approach. And as an observation of that, people can start doing from the 80%, doing definition of done, doing a pipeline, the run test, and they utilize SLAs, because most of the performance testing solutions has SLAs. They run test and they utilize plugins. They are all the load testing solution of the market as plugins that grab some indicators or some SLAs, trend them, create dashboards. You can also combine metrics from other monitoring tools like Prometheus, Dynatrace, but you are basically have to deal with lots of data. And you don't trust me a lot, the status coming out from the automation. So maybe it's a failure, but I'm going to check it out because maybe it's just a deployment problem. So you are asking someone to analyze every time. And this is not possible if you want to utilize performance on day-to-day basis. So we have to find a way to resolve it. Let's share some trends and initiative that we're seeing from the report. So the first thing is, on the next 12 months, most of the organization has committed to include 66% committed business metrics. So that's a positive change. 56% to do zero-touch performance as a self-service. So give the ability to train teams and be independent, to run their tests, get a feedback out of that. And I think that comes with the other last answer is 53% want to rate their apps. So if you want to be able to do a performance and self-service, you need to rate your apps. So how is performance traditionally measured? So we do some load testing against the app. We're going through we simulate the user that reach out to the front end. Network is involved. You have the core product. You can be on the cloud. And you're going to grab some indicators, and based on those indicators, make a decision out of it. And depending where you are, so your expectation, your requirements would clearly change. So if you are at a business level, you will probably look at metrics that are more like conversion rate, the voice of the customer, are they happy? the notes on the Apple Store or Google Play, for example, and that's a perceived experience. But then you have the guys that implements the performance coming from the AT. So they're going to check it out, check the weight, scale. Is it reliable? Does it scale? Is it available? The speed, the response times, all those type of metrics. So it's more about the actual performance. So there's clearly two silos going on, but clearly we observe that because of those importance of performance, clearly there's an impact on business if it doesn't respond well. So you need to measure. So we have to change the way we deliver performance testing. And performance, as a quote, is too important to be left to performance testers. So we have to change a bit. So for that, we need first of all an organization with a culture where performance is part of the culture. We expect some decent response times. We want to have all the teams utilizing performance. So we need to have some performance engineers involved as early as possible and interact with the business to define the requirements, what should be tested, what are the risks, and then implementing performance. You're going to test, and we have to monitor because we want a feedback. We want to monitor not only production, but dev, staging, pre-prod, whatever it is, to make the clear right decisions. So we're going to test earlier. Testing early means shifting left, of course. So for that, we are going to start by in a dev environment, testing components, API, one single thing. So here probably lies some service virtualizations, being part of the pipeline, testing the same thing to be able to detect regressions. Then we move on to integration. So we're going to integrate those components to each other. So by deploying various components, we introduce potential latency. So you can have other type of problems. So integration is also an important part where performance needs to be involved. Last, you have application end-to-end testing. So what we usually did in the past, this needs to be done, but not on every release. It really depends on the risk, of course. So the concept of testing early and testing components is very simple. I have this shiny building that has been built and deployed. But if I test it and I discover that the performance is bad just due to one single component, doesn't make sense. So if we start earlier, then we can detect these problems on that particular component and resolve it before it's too late on the cycle. So this building basically is built on bricks. So we have dozens of bricks, API components, and we're not going to test everything. We're going to test the one that are the most important. In terms of the services that represent the heart, the brain, the legs, the eyes of the app, the one that are really important. And then we want to analyze and make automatic decisions. Remember, we want to remove this 1 hour of a manual analysis to do. And for that, I think we need to stop using SLAs. SLAs has been a copy of functional world, but in performance, you don't have one SLAs. In your test, you have lots of various metrics, lots of different objectives. So we have to change it. So for that, we have to implement an approach that has been introduced by Google called SRE, Site Reliability Engineering, and where you have the SLI, SLO, SLA. So we're going to do SLA, SLI. SLI will be indicators. So I have response. I probably have SLI that are more technical and also business. So I'm looking at specific response times. I can look at CPU, error rates, and so on. So that's our indicators. And then in front of those indicators, I'm going to place objectives, probably thresholds, saying my response times is good if I have less than 2 seconds. My error rate is good if it's under 2%. Or you can do also comparison SLO as well. And then you have SLAs. So we're going to not place several SLA. We're going to place one, but we're going to evaluate every objective SLO that we have to calculate the score. And at the end, we're going to put one SLAs on our score. Say my test is acceptable if it's above 85, for example. And that it would be a way to remove this manual analysis. So if you go back to the previous slide that we had where we're spending 60 minutes here, we're going to use so NeoLoad as a load testing product. Jenkins could be the CI, and then it could be various load monitoring tools like Dynatrace, for example, or Prometheus and others. And here we have a framework called Captain that has inside the framework a quality gate. So we're going to use Captain just for measuring the quality of the releases. So we run the test, and then we have express specifically indicators and objectives. So based on the percentile 95, the CPU, the garbage collector. So we're going to trigger Captain, say, hey, grab those indicators. He's reaching out to every data source to get the values, and then in front of the objectives that we've defined, he's going to calculate past. If we pass, if we're warning, we're failing, and based on that, he was able to calculate a score based on all the objectives. And then, because we have an SLA on the score, we will make your test fail or successful. But at least because it's made on a lot of rules, we could trust a bit more what comes out of that mechanism. So that's a really important aspect of that. The second aspect is a couple of years back, we used to do load and performance testing, and then we were spending days or hours of building reports. So extracting graphs, putting some comments, analyzing, building a huge report. And then we were sending those reports to project leaders, QA managers, or whatever. And people were opening that reports. They were a bit scary to be open it because a lot of indicators that are pretty much specialized, very difficult to understand. So sharing the report through emails was not a solution. So then we moved to organizing meetings to share the output of our tests. So depending on the people that was involved in the meeting, we will have to change the messages, of course. But again, people going to those meetings could be afraid because you're going to speak to a bunch of nerds. So it could be quite stressful. So we need to change, and I think sharing our cookies is the solution. So every type of user has different type of tools. If I am a product leader, I have a specific bunch of solutions. A performance engineer has other solutions. So the idea is that we need to expose the metrics coming out, expose the status coming out. So if people do some automatic reporting, they will be aware that we are doing on continuous basis what are the status. And this is the main reason of transforming testing by combining tools to each other with Spira and NeoLoad, and that's the value of that. So how can NeoLoad and Spira help you? Of course, making things visible. First, let's have a look at the architecture of NeoLoad. So NeoLoad has if you look at the left side here, when we build scenarios, we need to install one of our controllers. So we're going to record SAP traffic, Citrix, or web. And then when you're going to run the test, you need components to generate the load. So load generators could be on-prem or on the cloud. What we introduced a couple of years back now is the web dashboard. So basically controllers and load generators, controllers are required for designing. And then when you come to testing, you need only for the duration of the test. So the web is the central repository that will manage your licenses, your test results, your team, made for collaboration. And you can also automatically manage your load testing infrastructure to spinning up, tear it down, so better resource usage. In front of that, we have tons of API, and with the help of the API, they'll allow us to build a lot of integration with test management product, with CI, with other things. The way we design our tests are depending on the where you are, in which stage. If I am doing integration or pre-prod or end-to-end testing using SAP, Citrix, or even the browser with that could generate tons of requests, then I would prefer to record it with a GUI-based product. So on the right side here at the GUI-based project, you can record. It makes things easier, simple, very simple. And then you have other requirements from the moment you want to test API. If I test an API, if I do it from a GUI-based product, I will have a lot of clicks before I'm able to run a test. So sometimes it's faster to just drop a few lines of code there. That's why we have a JUnit format and we have a YAML format. And at the end of the day, it's formats. We have project in the middle, so you can easily compare and share, reuse. So this is the core spirit behind the design. As an advantage, our product is, if we have to have one message, is better TCO. That's the idea. We are faster when it comes to designing better usage of the infrastructure. So basically, when you are in Agile DevOps, it makes totally sense. Here we ask to a few customers based in Europe and US to measure the time they were spending on sub-activities related to performance. So in the first line, this is the time they spent using JMeter and Load Runner. And then they did the same exercise by building the same thing in NeoLoad. And there we're observing to saving 60% of the time. And then we have one of the feature called user path maintenance to maintain your testing assets. And here they were observing 90% of the time. So it's pretty impressive in terms of number. In terms of technology, we support Citrix. So we are pretty much enterprise ready. So Citrix protocol, ASAP GUI, Oracle bundles, and also everything that utilizes the HTTP transport layer. So either a pure web retailer websites or pure API microservices architecture, or modern package apps like SuccessFactor, like Guidewire. A lot of package apps now are based on HTTP, so we support quite well. We also have IoT support and blockchain as well. All right, so enough of slides. Let's jump to the demo itself. So here I've prepared two things here. So first part of the demo is utilizing an AMI based in Amazon, Windows based. I have installed on top of that the remote launcher from Inflectra. So this launcher is obviously connected to SpiraCloud, where I will have some tests that I can automate. So here in my case, I have configured to run once a day. And I have several things. I have first the controller, traditional controller. So then I can see the project, I can launch test. And this will use the integration that we have with Spira. We also have another approach where I want to interact Spira with the web. So we have web services as well, and this will push the data back to the web. So you can either look at the assets in Spira or direct it to web dashboard. So you don't have to necessarily open the project anymore. You can basically stay up with those browsers. All right. So it's demo time. Let's have a look at this. And then we have another section later on a demo more on the agile component level testing, all the things like this. All right, let's jump to the demo. All right, to make this environment possible, the first thing that I need is to get NeoLoad. So if you launch a trial of NeoLoad, then you will be able to get a license and our core product NeoLoad. That's from a Neotys perspective. So here you can see I have already pre-installed NeoLoad. It's part of my laptop. It's already here. The second thing that was required here to make this, to transform and communicate our results between both tools. Here I haven't started. I'm using Spira Test on the cloud, but also you need to utilize the remote launcher. So here you will have to get the remote launcher. I have it installed here. It's running on my laptop already, so I can look at that. I have the client setup, reaching out to my to Spira, and I have two add-ons. So there is a in the support page of Inflectra, there is add-ons here where you can find the add-ons for Spira Test. There are various add-ons, and one of the add-ons that is available here is obviously NeoLoad. So that will allow you to command. So that's for the product side. So once you have a NeoLoad installed, the remote launcher configured, then you will have to add them to Spira. So here I have a, it's not in English, sorry, because it takes my local language settings, which is French. But here you can see that I have built two things. So I have several scenarios built in Spira. One of them is a NeoLoad web test, and I have configured to utilize my launcher, and it's going to run on a daily basis, and he's going to interact with the launcher. So the launcher basically is this machine. Spira is sitting on the cloud, and every 1 minute, because it's connected to Spira and their launcher, he's going to, not every minute, sorry, it's going to be insane. Every hour, he is reaching out to this machine and triggering the test. what do you get out of a test execution? So if I jump back to here and I select here a set of tests here, you can see that I am getting out feedback. So here I can see here all the various test execution that has been executed. I can, of course, do some dashboarding. If I look at one of this specific execution, I can see a couple of response times available here, a couple of indicators, the hit per second, and so on. So that's a couple of core metrics that NeoLoad grabs back from NeoLoad. You will also have a couple of top 5. So I think the top 5 is pretty interesting. So what are the major alerts? What are the major response, the top 5 average response times and so on. But also I can look at the expected results. So we have if you have SLAs defined in our product, those will be reported back also to Spira and determine if it's passed or failed in terms of results. So that is a way of easily communicating metrics that are exposed in NeoLoad to Spira. NeoLoad as well, because we are running it, you will have the results as well here. So I can I don't have to be connected to that machine anymore. If I want to have more details, I can jump to that URL, and that brings back to NeoLoad Web. So this is the UI of NeoLoad Web, where I have looking at the specific test results. But if I go here, I will only see all the test results related to my project. So here, workspace default. And you can see here I have a bunch of different results here. Of course, I can trend those. So I can basically here select the project called sample demo, dem PO, whatever it is. I can trend them with the last 50 tests. So I've executed since a couple of now several tests through the remote launcher, and those are trended directly. Of course, I can jump to one of the reports. So here, one of them has failed here, so I'm going to look at it. And by jumping into the dashboard, I will be able to create my graphs, similar to the type of things that we are used to when we analyze our tests from the testing product. So either pure metrics reporting response times or hit per seconds or throughput, or on the other dimension, which is going to be the monitoring. So here I can check it out, how the Apache server is behaving, and do that. So basically, I can still run it through the remote launcher or from Jenkins by utilizing the remote execution of Spira. And that will basically run the test, report back metrics in Spira, but also because the test results is on the web, I can easily jump it back here and do my analysis. So that's the core advantage. I am pretty much giving the metrics and the visible within different teams, either pure QA managers, either more performance engineering from a NeoLoad standpoint. Of course, to make this possible, you need a project. So here, this is the NeoLoad project that I've built. So I've saved it. I have correlated, so everything is being already prepared. And I have that's on the GUI based. I will show you later on what is the YAML technical language as well. And here I have one test, the one impact local, the one that has been reported back in both tools with the ramp up. So this controller that you can see here is primarily made for defining your test, and so on and so forth. So that's the first portion of the demo. Let's jump to the other one that will showcase, like I explained, the notion of quality gates. All right, so the second part of the demo. So here in this demo, we are showcasing the usage of NeoLoad in the pipeline. And I mentioned this quality gate, the importance of having something failing a test or precisely based on rules, SLA, SLI, and SLO. So here, this is the purpose of the demo. So first of all, everything that I'm showing you is available on GitHub. So GitHub, there is a specific organization called Neotys DevOps Demo. and that has basically all the various pipelines that I've prepared. Basically, I have a Jenkins server sitting on Amazon that has jobs for each of those components and pipelines. So he basically is getting the Jenkins file in GitHub and running the pipe on the pipeline. Otherwise, on the server itself, I have a Neotys, of course. I have Dynatrace for the monitoring. And it's a microservice architecture. So there's pipeline that will basically spin up only components and pipelines that will integrate those components. So that also the staging pipeline. The app that I'm testing, like I said, is a microservices application. So the front is the component that assemble every of those microservices. So that's why the front will be considered like a staging where you integrate everything. But then we have specific areas of the app. So it's an e-commerce website with the catalog that is on database, the order as well, the user, the card, the payment, and so on. So this is the architecture, and every of those components, cards, catalog, payment, has their own pipeline, and that follows this flow here. So first, we're going to check out the code that is stored in GitHub. We're going to build the app. We're going to build a container. Once the container has been built, we are going to push it to Docker Hub. And then once it's been pushed, we are going to deploy that service on the machine with the Docker. Then we run tests. So we deploy the load testing infrastructure. We launch test with NeoLoad and the Dynatrace integration. And then we go through the steps that I described previously in the slides to evaluate. So using the quality gates, utilizing Captain. And everything is positive and good feedback. Then we're going to promote the container. So we're going to take that container that we've built, in this slide, so card dev 01. We're going to promote it. So card dev, card staging 01. To promote it to staging, because staging will take all the container that's been marked as staging ready. Okay, so like explained, so every thing that I'm going to show you here is accessible in GitHub in a public repo. So it's an organization called Neotys DevOps Demo. You see here there's lots of different projects, and each of them is an individual pipeline to build the application. So that's the app. It's a web app where you can buy socks. It's pretty amazing. It's a demo app. And like I mentioned, everything has been driven by Jenkins. Jenkins, the master of ceremony. You can see here I have various pipelines for each of those components. And like mentioned, front end will be sort of the staging testing from the end to end. So how does that being represented in NeoLoad or in a pipeline? And to do that, I'm going to show you an IDE. So here it's IntelliJ, so you can use Eclipse or others. This is where basically it's pointing to the GitHub repo, and I have, like showed you, I have one folder for each individual pipeline. And I have components that are built with Java. So it's going to use our JUnit library. I'm not going to go too deep on that. And it utilized Dynatrace. Dynatrace is part of the picture. In terms of pipeline, here it's using the Groovy approach, where I define the pipeline, and it's going through the every steps that I described in the slides, building, deploying. And here I want to be smart, so I'm going to deploy on the fly with containers, the load testing infrastructure, so controllers and load generators, and then utilize them later on here to test. So I'm using one of our component called the NeoLoad client that interacts with the web to launch the test. To utilize the quality gate, of course here, because the indicators that will measure if our release are passed or failed is in Dynatrace. So I'm we have enabled the Dynatrace integration. To do that in a Java way with the JUnit library that we have, you just have to pass the specific variables to enable the Dynatrace integration. Once you do that, then the test that has been generated by Java will have the Dynatrace integration. What about the other way? So we have another way of describing our tests out of the GUI and the Java. It's the YAML description language. So the other components here, catalog is a Go service. So the team obviously has no expertise in Java, so they're going to define the test with our YAML description language. So here, every notion of a Neo project is here with the variables, the server, the design, the user path. Like I mentioned, this is mainly to do component level testing, and they're doing a couple of API. You can do extraction, assertion, you can do everything that is possible in our product. And here I'm going to enable the Dynatrace integration. So here there's a project setting where you define a couple of properties, and then I'm going to attach to my individual tests the fact that I want to have the Dynatrace integration. So you can pass that. So that's typically how it goes. And then I'm going, so Dynatrace has built Captain. So to be able to use Captain, I have deployed on a small box, a light version of a Kubernetes cluster, K3S. And I haven't deployed it. So only Captain Lightweight, which has only the Dynatrace, the quality gates. And Captain has an API. So in order to avoid coding edge individual code to start evaluating the release and score it, I am using one of the library that has been built here, the Jenkins library. So I just have to add that library. And once I have that, I can basically you can see here, initializing Captain, I'm passing some resources. And the one I'm interested more about is at the bottom where I evaluate the gate, quality gate here, where I am sending here with this library a start evaluation event. And then I'm opening the link so we can see the results that come out of it. So you can either describe the SLIs in your repo and push it with the add resources, the command I showed you really quickly when I was scrolling. So you can add here a Captain repo with the SLI, which are the indicators you want to collect on the SLO. So that will be a technical way of doing it. If you don't want to do that because it's going to be too much technical, then in Dynatrace, what you can do is build dashboards. And dashboard, I will have a specific naming. So here I build one with the cards here, which is here, and you can see that there's a clear naming available. So Captain, quality, gate, project, service, and so on. And then I'm building the dashboards based on Dynatrace metrics. And because NeoLoad expose as well metrics in Dynatrace, so we're exposing metrics in Inflectra, but also in Dynatrace, this is transforming things. Then I can create dashboards mixing pure Dynatrace metrics, pure NeoLoad metrics, and that will be the definition of our SLO. So if I take one of the metrics here coming from NeoLoad, in this dashboard, the name of the dashboard is important. You can see that I'm defining the name of the SLI and the thresholds that come out of it. And basically, once you do that, Captain will grab the dashboard that has the right name and collect the various indicators based on those metrics that I showed you. So out of that, what you get out, Captain has a UI. It's called the bridge, and here I can see the results that comes out of the various quality gate evaluation. So here, the cards, that's one of the pipelines that I launched. You can see that the evaluation has been started, and I'm getting out a heat map. And I didn't define the SLI technically. I just built a dashboard, and you can see that he has retrieved the various metrics coming from out of NeoLoad, Dynatrace, and others to identify if everything is green or red, and provide a scoring. And then the Jenkins will fail based on the score. So here we have 100 of 100, so we are pretty good. So that's why the build in Jenkins went very well. Okay, so we saw a lot of things here today. I think as a conclusion, we can say that there are a lot of tools that we are utilizing on a day-to-day basis in our project delivery, tools to monitor, tools that will allow you to load test, tools that will track the requirements, the status out of coming out test and releases. Um, we cannot now have tools sitting aside, not discussing, like a silo. We need to share things, communicate metrics between each other because we don't have much time anymore. And especially if we work remotely now, sending in emails and waiting for a meeting doesn't make sense. So be smart, transform your testing, make your tools communicating with each other. All right. I hope you enjoyed. See you for the Q&A.